So continuing our conversation about buffers, we are going to take a look at the details of answering a buffer question when you add acid or you add base. How is that going to change the pH of that system? So here you can see the information. We're going to calculate the pH of a buffer solution of ammonium chloride. What's the pH after the addition of 20 milliliters of sodium hydroxide if we're starting out with 80 milliliters of the buffer? So game plan, couple things we have to do. First and foremost, pH of the buffer before we added sodium hydroxide. Then we want to figure out the concentrations of all the species after the addition of sodium hydroxide. So this is going to be similar to what you did with titrations. And then we want to find the new pH using the idea of the hydrolysis reaction. So that's the reverse reaction. So step number one, determine the pH of the buffer solution. So what do we have? Here's our reaction. We've got ammonium breaking up into ammonium ions, and hydroxide ions are reacting with water to produce ammonium ions and hydroxide ions. So initially, based upon the information from the last slide, ammonia is 0.30, ammonium is 0.36. We're going to lose the reactants, gain the products, and so in the end, these are going to be our concentrations. We need to figure out what X is in order to figure out OH minus. So the Kb of ammonia is 1.8 times 10 to the negative 4. So we're going to put in our numbers, solve for pH, and here I've approximated. You may not want to do that. Maybe you're just going to keep it because of your cell function. You're going to keep it plus X and minus X, which means your answer is going to be slightly different than mine. That's okay. We wind up with X being 1.5 times 10 to the negative 5th. And so the pOH, therefore, is 4.82, which means the pH is 9.18, which makes sense because this is a base. It better be above 7. So that's what I've got with just the buffer. So now let's consider what happens when you add the 20 milliliters of sodium hydroxide. So we need to find the new concentrations. So the final volume, we had 80 milliliters of buffer, 20 milliliters of sodium hydroxide, so total volume is 100 mils. And we're going to use a dilution equation to figure out the new concentrations. So the ammonium ion started off at equilibrium. For the buffer, it was 0.36. We had 80 mils of that, but now we're diluting it to 100. So starting off, the new concentration is going to be 0.29. The hydroxide ion that we added is just the concentration times its volume divided by the new volume. And then there's ammonia. So we've got the three concentrations. In order to determine the final concentration, we have to have neutralization take place. Okay, so sure, I needed to put a rectangle around that. So we're going to do, we're going to do the neutralization. So remember, I had this, I think, initial and final instead of start and end. So we added 0.01 moles of or 0.01 molar of sodium hydroxide. We're going to use up 0.01 molar of the ammonia. So it started at 0.29. It's going to drop down to 0.28. We're going to increase the ammonia by 0.01. So we're going to go from 0.24 to 0.25. So that's what's going to happen. The OH minus is going to combine with the cation, the ammonium ion, and make more of the base. So this is essentially the neutralization that's happening. So now we have our concentrations of ammonium ion and ammonia base. So now what we want to do is we want to calculate the new pH considering what has happened. So again, we've got this reaction. We want to know the Ka, so what's happening? The NH4 plus is going to react with water to give you NH3 and H3O minus. I'm not sure I like that. Well, Yeah, that's the way AP is going to have you. That's the way they want to see it on the test. So we're going to write what's going to happen to the ammonium ion. So the conjugate acid is the reaction that we're going to take a look at. So ammonium ion reacting with water to give you ammonium. So this is a Ka now. So ammonium is acting like an acid. It's donating H plus to water. So we've got the Ka. We want to know what the H plus concentration is going to be. We know the ammonia concentration. We know the ammonium concentration. And how do I get this Ka? Oops, shouldn't have stuck that in there yet. The Ka, remember, is Kw divided by Kb. Ka times Kb equals Kw. So 1 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5th gives me 5.6 times 10 to the negative 10. So that gives me a way to figure out the H plus concentration. And so I solve for H plus and I get that, and then convert it to pH. I get 9.20. Again, I can use Henderson-Hasselbalch. The pH equals the pKa divided by the log of, or plus the log of the two ion ratios. pKa is 9.25. In the original buffer, the pH would have been 9.25 plus the log of those two original concentrations. So 9.17. After the addition of the sodium hydroxide, our concentrations changed. And so we've got 9.20. So notice that the pH did not change any significant amount because of the buffering system of the base and the conjugate acid. All right, so there you've got an example. We're going to do a lot more in class, so be prepared, but please do read through the book, read through the sections on buffers, do the examples, study the examples, as well as having watched the video.